Good morning, Tehmina Khan is here in TKMaths 1. In today's video, which is a series of videos for understanding Poisson distribution, which is a part of the syllabus of A-level mathematics S2. So these videos, which will be consisting of four videos, will cover the Poisson distribution overall concept with the example of with the solved example. So this is the syllabus. Rather than you read it, I have put it down in the pointer form here. So basically, if you see, there are 5 points. Number 1, you should know what are the conditions of the Poisson distribution. Then you should know, in a very simple case, how to calculate the probability if Poisson distribution is given to you. Question is around it. Then about mean and variance of the Poisson distribution you should know. The Poisson distribution as an approximation to the binomial distribution. So if the question of binomial distribution is given to you, then how you will use Poisson and get the answer approximately. Binomial distribution you have done in S1 last year in AS mathematics. But when I will solve the example, the examples are solved, which I will explain to you to save the time. I have already solved them because these videos are quick recap of the Poisson distribution. So I'll explain and recap the binomial distribution again. The last one is the normal distribution with the continuity correction as an approximation to the Poisson distribution. So if a question is given in the Poisson distribution form and you want to apply normal distribution to get approximate answer, then what is the technique and why do we apply continuity correction? Any idea? Because normal distribution you have studied last year. Normal distribution is for continuous data, whereas Poisson distribution is for discrete data. So when we make a connection between discrete data and continuous data, we apply continuity correction. So let's just start with the first one. The conditions. So overall I will make, I believe, 4 to 5 videos. Let's say I'll try to keep the length of the video around 4. And for more examples of these questions on Poisson distribution, you will find the link in the description, right? So here I have just taken 1, 1, 2, 2 example to explain the meaning. So let's say start. So first of all, what is a Poisson distribution? So basically the Poisson distribution is a probability distribution for discrete random variable, and it talks about occurrence of a certain event in a given interval of time and space, right? So if you know that x is a variable which is talking about the number of occurrence of a certain event in a given interval. By the way, if you are finding this wording difficult to understand, when the question will come, you will grasp it. Don't worry. So x is the random variable which is following Poisson distribution. Then it means there are 4 conditions. You will see in the past paper question they often ask state 2 conditions, or maybe they give you 2 conditions in the question and it will be asked state other 2 conditions. So you should know all 4 conditions. Number 1, independently, singly occurring, randomly occurring, and at a constant average rate it is occurring, the event we are talking about, right? So these are the 4 conditions you must know. Now, how do we write this distribution? Because this is very important. Like you have studied in S1, in normal distribution, what was your parameters? You remember in normal distribution, it was mu and variance. Similarly, for each distribution, there are certain parameters used to calculate the probability. So in Poisson distribution, there is only one parameter which is called lambda, and this is how it is written, right? So now, how do you write Poisson distribution? This is the way it is written. Now, if you remember last year when you were writing normal distribution, how were you writing it? Like this, mu and variance, right? So Poisson distribution is written like this. So lambda is the only parameter which is used in Poisson distribution, right? And how it is read? So this denotes that x has a Poisson distribution with lambda, and lambda is what? Mean and variance both. Okay, in Poisson distribution we will discuss about it. Then mean and variance is the same thing. Now, how to calculate the Poisson probability. Now this is the main formula, this one, right? And just a minute. Okay, so this is the main formula, because in the question now, example 1, we will see what is lambda and what is x, and then we will simply plug it in. So you have to remember e power lambda times x over x factorial, and we are calculating, for example, probability of x is equals to maybe a 2, 3, 4, whatever. That number will come here and lambda will come as a mean of the question. So let's see this question here. Example 1. The number of amoebas in the water from a particular pond follows a Poisson distribution with the mean 4 amoebas per 10 ml of pond. Now this is something important. Okay, in how many milliliter of water, how many amoebas are found? So in 10 ml, 4 amoebas. Find the probability that in 10 ml of pond water, there are exactly 5 amoebas, at most 2 amoebas, at least 1 amoeba. Now, in the question, the mean is given for 10 ml. And in the question, probability is asked for the same 10 ml. So when the amount is same or time is same in the question, then your mean remains same, right? So when it is saying exactly 5, it means I will find out probability of x equals to 5. This is what I have to find out. And the formula will be, by the way, if I want to write this, how will I write it here? I will write it like this, right? This is my question from the, information from the question. So I will write e to the power minus lambda power x over x factorial. I have solution here, but I'm just telling you how do we write it so that you can recall better. Okay, so let x, because we do tell what is x here, what do we mean by x. Okay, so this is how you will calculate it. I have already shown you here exactly 5 amoebas. When it is saying at most, what is the meaning of that? It means x is less than and equals to, right? Most mean less than and equals to. So when it will be less than and equals to, it means you are calculating x0 plus x1 and 2, right? Let's see here. See, 0, 1 and 2, and the formula is applied here. By the way, let me tell you one thing here. This is written in this question, but whenever you will see marking scheme, straight away this step is written there. And you can also write it directly, because e to the power minus 4, which is e to the power lambda, is common. So you can take it out, right? And so what is the technique to remember it? E power minus lambda out, then it is lambda power x over x factorial left. Okay, so when x is 0, because we are starting with 0, this will become 1. Okay, when x is 1, it will be lambda power 1 over 1 factorial. Then when it is 2, lambda power 2 over 2 factorial, lambda power 3 over 3 factorial. This is the way to make or solve the question faster, quickly. Okay, now the last part of the question was at least 1 amoeba. Now this is very, very important question. At least 1. You need to understand this. When we say at least 1, what does this mean? It means probability of x is greater than or equals to 1. Now when it is greater than equals to 1, what does this mean? It means 1, 2, 3, but there is no end limit. So till where you will calculate the probability and end up. In these type of cases, when it is at least 1 or at least 2 or at least 4, what do? We do subtraction case. So I will do 1 minus probability of x equals to, when I'm starting with 1, what is missing? 0. So that will give me all the probability other than x equals to 0. Right? Let's see here. This is what I was explaining to you. And exactly because there is no upper limit, so that's why we will subtract the probability from 1. See here, no amoebas mean x equals to 0, which I explained to you here. And then I will apply the formula. Now, if somebody is confused about this formula, let's see here. 1 minus e power minus lambda power x over x factorial, right? And it is x equals to 0. And lambda is what? What is your lambda? 4. It was the same. For 10 ml, it was 4. 1 minus e power minus 4. Sorry, minus 4. 4 power 0 over 0 factorial. And you know anything to the power 0 is 1. And 0 factorial is also 1. So what you are left with? This thing. So always remember, when it is x equals to 0, then in the formula, these things become 1 and you are left with e power minus lambda. And that's why it is written like this here. Now let's see the last example for this video, and then we will continue in video number 2. So again we are calculating simple probability. Or you can try it out yourself, put the video on pause and try it. By the way, each and every example which I have taken has something new to learn. So if you read this question, what do you notice? What is new in it? Something tricky where students at times make mistake. Part 1 is simple. So let's start, then I'll tell you where is the trick. Or if you want to try it yourself, you can put the video on pause. Weak spots occur in the manufacture of certain cable independently and randomly. Now two conditions are given to you here, okay? Independently and randomly. At an average rate of 2.5 weak spots per 100 meter length. So in 100 meter length, what is the lambda? Or average is what? Mean is what? 2.5 weak spots. Find the probability that in 100 meter length of cable, there will be no weak spot. No weak spot means you have to find out the probability of x equals to 0. And your lambda will remain same 2.5. What is the reason? Because the length of the cable is same 100 meter. And when you will calculate more than 2 spots, weak spots, you will calculate this thing. And I just told you, whenever it is greater than 2, it will be equals to what? 1 minus probability of x less than equals to 2. Because 2 is not included here, so it will be included here. So it will become x equals to 0, 1, 2. So let's see this calculation, then I will come to part 2, okay, at least. So I wanted to explain to you first. Sorry, I wanted to explain to you first, and then I will show you the solution here. See here. So I have explained to you here, x equals to 0 mean e power minus lambda power x over x factorial, and x is 0, so I will be left with this. Second was saying more than 2 weak spots, so it is x greater than 2, right? And I told you here the reason. Okay, whenever we have greater than, we always do 1 minus. This is the only way to do it, because there is no end limit in Poisson distribution. Okay, so this is how you will calculate. We have seen in part 1. So I think this is not a problem. So tricky part is last part. What is that? Paul cut 8 lengths of cable. Okay, now he has 8 pieces. 1, 2, 3, 4, 5, 6, 7, 8. And what is the length of each? 100 meter. So again, because I'm taking the length same, my lambda will remain same, 2.5. Find the probability that exactly 2 of them have no weak spot. Now what is this? If you see, this is actually connected with binomial distribution. So that's why it is said for S2 that S1 is your prerequisite. You should remember it, you should revise it, right? To find the probability that exactly 2 of them. So it means I have to find out the probability of x is equals to 2. And what is given to me? What is given to me here? It is actually binomial case. It is NP. N is what? 8. and P is the probability of no weak spot. So if we see here, no weak spot was given here. So I can use this E minus 2.5. You agree with me? And then I have to find out exactly 2. So this calculation I have to do. Now if you remember here, the formula for the binomial, which was N, C, R, P, R, Q, and minus R. And P is your this probability. So you will plug it in here, right? I will show you here in the last part here, calculation, but this is how it is done. I hope you understood this, and this here I will stop this video because it is getting lengthy, and rest of the topic I will continue in the next videos. So if you have any query, you can ask me in the comments, and please share it with your friends. Press like and subscribe button. Thank you very much for watching. Take care. Allah Hafiz.